So before we dry run our program, we should of course write out the stages, as you can see was done for the program on page 62. So let's check the stages of our program. It should be something like this. First thing we need to do is we need to input the number. So stage 1 of our program should be INP. Stage 2 of our program will be STA, which you remember means store, so star num1. Now num1 in our case of course is going to be 5, and then stage 3 will be input, and what this means is we are now going to receive the extra number which is being input. So the first time around we're inputting num1, which is of course 5. The second time around we're inputting num2, which would be 7. Okay. Now for stage 2, we will add a new function from here, add num1. So this means we are going to firstly put our second number, num2, into the accumulator, so the accumulator will have 7, and then we're going to bring the 5 out of the storage area num1 and add it also to the accumulator. Okay, after we add num1, we're going to output, but of course this time what we are going to output is num1 plus num2, which equals 12. And then after output we need to halt the process, and finally, as you did in 5.2.1, we need to put num1 dat. Now when we num1 dat, that is going to label the memory location of where num1 is, as it did in 5.21. I'll make that a little bigger for you to follow. So those are the stages of our program, and remember, when we write the stages down here, instead of having 1, 2, 3, 4, 5, 6 with the program counter, the instruction will start at 0. Okay. So our instructions will be 0, 1, 2, 3, 4, and 5, and our program counter will be 1, 2, 3, 4, 5, and down here it will be halt, because the program will end at stage 5. And then over in the accumulator, this is where we will store our numbers. So initially we will store the number 5 when it is input, and we will retain the number 5 for stage 2 in the accumulator. And of course the number input in the very first stage is going to be 5, nothing output and nothing stored yet. Then in stage 2 we will of course store 5 in num1. Then in stage 3 we have input again, so the accumulator, instead of showing 5, will now show the new number input, which is 7. But of course 5 will remain in storage as num1. Then we will add num1 to what is in the accumulator, meaning 7 will be added to 5, so that will give us the accumulator 12. Remember, we spoke about how the accumulator is like a calculator. So there will be no input in this stage, and nor will there be any output just yet. And of course num1 shall remain 5. Now that we have added input, remember, the program would also no doubt store number 7 as num2, but we will not go that far today. Anyway, so for stage, we are now at 1, 2, 3, 4, 5, stage 5 according to the program counter. And this is the output stage. So here our output, we will print for the user the number 12, which is the two numbers added together. There will be no input. Num1 remains 5. And once again 12 will remain in the accumulator. And we will not do this labeling stage in our table where num1 is labeled. We will simply halt. I'll just put an H for halt in all the remaining boxes, because this is where the program and our table will finish.